Good evening to all. Sorry to keep you waiting. Is my voice audible to all? Okay, great. So, okay, Rezi. Okay, Sandeep. So, actually, I have not prepared anything for today's class till now. So, what I want is I have some videos definitely for you people, but I just want to know what, since I have taken almost every aspect of management with you. I mean, I have discussed more or less every topic related to management. So if you have some general questions, if you have some general topic which you have not understand or which you want to understand from me, if you have any doubts, any clarifications, you can just go ahead and write that the name of the topic which you are really facing problems, so that I can discuss that particular topic with you people. Or I have some videos, general videos for you, learning videos, I can share that video. Just go ahead and write. If you have any topic in which you are facing problem, in which, or the topic which you are not able to understand, any topic. I mean, I have covered lot of topics with you people: IT management, MIS, ERP, CRM, marketing, operations, HR, supply chain, advanced supply chain management. Lot of topics I have: organizational behavior, business policy and strategy management, entrepreneurship development, total quality management, product management, relate principles and practice of insurance, risk management. So, do you have any problems anywhere? Anybody? Kelvin, Sunil, Rezi, Sandeep, Satish. Any problem with any topic? Anybody? Okay. So, Sunil says it is okay, would like to see some videos to refresh. Okay. Rezi says, sir, I would like to know about quantitative techniques which can be covered by Vasis sir, which was covered by Vasis sir. If you can explain about that topic in some class, will be more helpful. Okay. So in quantitative techniques, anything specific, Rezi, you want to know? Anything specific you want to know in quantitative techniques? Arithmetic. Okay.
The respective phases will mingle with other phases, so it's like completely cut off. So this is a typical waterfall methodology wherein once you
Alright, hello choir people that are here today. So today we're going to learn about this Sdlc. Here's how the program works. That's enough for programmers to figure out how to write that program. So that's functional specification.
All right. Hello, choir people that aren't here today. So today we're going to learn about this Sdlc thing.
All right. Hello, choir people that aren't here today.
All right. So Sdlc stands for Software Development Lifecycle, and this is
Today we're going to learn about
pretty much how
Sdlc.
So this video is about software development life cycle. How we develop a software, or how rather a software is being developed in a software company. Since you people have not told me any topic in which you are facing problems, so whatever I feel like I'll be just discussing with you today. Rezi, for that arithmetic part I'll prepare, and definitely I'll discuss with you. What I have done for all you people, I have I have prepared that March calendar for the classes. The last two class of the March calendar, that means I'll tell you the date, just a second. What I have done in that particular March calendar, the last two classes of the month, I have left it for the students class. I mean, whatever challenges or problems you have, we will be discussing only those stuff in the last two classes of the month, March. So the date, so I want that you people should come up with certain questions. If you are really facing any problems, so I want that you people should come up with certain questions, so that we can have a discussion on. I'll tell you the date. In a second, I'll tell you the date what I have scheduled. Okay, so the date is 27th March and 30th March. So on these particular days, we'll be discussing. It's a relevant topic class. So Rezi, just remind me at that point of time. Just remind me on 23rd or 26th. I have a class with you on 23rd of March and 26th of March. So just remind me on 23rd, or either on 23rd or on 26th, the topic which you want to take up. Then definitely I'll be covering that topic. Okay. Okay. Everybody, this is for everybody. On 27th and 30th, on 27th of March and 30th of March, I want that people will tell me what problems you are facing, so I'll be conducting class on that particular topic. And it is open for all. Now let's get on with the video.
that aren't here today. So today we're going to learn about this Sdlc thing. Alright, so Sdlc stands for Software Development Lifecycle. And this is pretty much how professionals build software. Let's pay attention. Should I blank the screens? No, I shouldn't. You should take notes on this, by the way, because when the midterm quiz finally does happen, you can bet that information from here will be on that quiz, so it'd be good to take notes. Alright, actually, okay, so what is the software development lifecycle? The basic model for the software development lifecycle is this. You start off with requirements analysis. You move into a design phase. It has an implementation phase, testing phase, a release phase, and then it kind of cycles through. It's a life cycle, so you go back up to a requirements analysis again. And we'll talk about each of these phases in detail. Okay? So the first of these is requirements analysis. In this phase, you're working really closely with customers. You're identifying what problem it is that you're going to solve for the customer. Now, the customer might be yourself. The customer might be a lot of people, maybe only one person, maybe a company. There's lots of different possibilities here. Oh, one thing I was going to talk about too, just talking about the basic model. There are different variations of this, but pretty much everyone that writes software is following this basic life cycle to some degree. You may be writing the program as a single person doing all of these steps. You might have it so that you're a larger team where different groups of people are doing every step separately. There's lots of different ways to actually do this life cycle, but these are the basic phases, and no matter how you do it, you're pretty much doing these phases to some degree. And how you actually go through that depends on which actual process you're going through. All right, so the requirements analysis part, before you can really get started, you have to know what it is you're going to build. And so the requirements analysis focuses on the what, not how. They don't talk about how you're going to do it. They just talk about what it is your program is going to do. The end result of this analysis is a functional specification. It's a document that tells what it is the program has to do. That's very similar, well, in fact, that's kind of what all your programming assignment handouts have been, are functional specifications. They say, here's what the program's supposed to do. It's going to look like this. Here's what all the buttons are going to do. When you click on them, here's how the program works. That's enough for the programmers to figure out how to write that program. And so that functional specification is reviewed by the customer to make sure that you're actually you're doing what we said we're going to do. And then the designers, the people who design the software, review that to make sure that it answers all the questions that they have. So a lot of times you'll go through and actually design and implement this program and realize the specification isn't clear on this one point. And so you have to get more information. And so you'll want to do that as early as possible. Okay, so the next phase is design. And this is where you're focusing on how the program will do what you need it to do. And this is the process of breaking that problem up into smaller pieces. And we've done that for our other programs. We'll talk about, here's what the problem we're going to solve with this program. We break it up into smaller pieces that are easier to implement. And each of those small pieces are called components in many cases. And each component has to work together to make the whole program work. And so the design phase, you'll build what we call an architecture, which is kind of the overall layout of components and talking about how those components work together, and then you have design for each component, how you do what they do. And the end result is going to be some kind of design specification, a document that describes how everything works, how everything's put together, and how the program does what it does. And that specification is reviewed by all the designers, and the implementers, people that actually write the code that fulfills that design, will review it to make sure that it can actually do that. Okay, so the implementation phase, this is where you actually write the code. This is where you're in the programming, Visual Studio, whatever it is, you're writing the code according to the design you've had. Often this is the shortest phase of the entire process, which is interesting because you learn how to write programs and you learn how to do all this, and when you actually do it professionally, sitting down and writing the code is the shortest part, and it really is that way. The end result of this is the actual program code, and that code is reviewed as well by designers, the coders, and the testers. So very common to have, you're working on a programming team, you write some code, and you pass it around, and everyone reviews the code, and they'll make suggestions. And we haven't really done that much in this class, which we kind of should, but just isn't time to really do that. But if you did want to give your code to someone else in the class and have them look at it and make suggestions, that can be a really good thing. You can learn a lot because this whole process of reviewing code actually makes everyone better programmers. If you find out a different way to do things, you just learn a lot. You learn from other people's experience, and other people learn from your experience. Okay, the next phase is the testing phase. This is where you verify that the code works according to the way it was specified, the way it's supposed to work. And testing is a lot harder than you think, because you're always looking for corner cases, and you're producing this test plan, which lays out exactly how you're going to test everything and what it is you're going to test. And the end result from that, once you've done the test, is a program that actually works. So this can be kind of difficult. As you know, when you worked on your own programming assignments, you'll get all the coding done, you'll think everything's great, you'll send it to me, and I'll say, hey, this looks good, but here's 5 things that it's doing wrong. And you have to fix that. Okay, so obviously you didn't test your program if that's what happened. You didn't think to do those things. If you did, you would have found those bugs and you would have fixed them. And so it's really important to have this, when you're in this testing phase, to really think about all the ways that your program needs to work. And you actually, a good tester will read the functional specification, and while they're reading it, they'll think about how could this break? How could this go wrong? What could I do that could maybe do this, that could make this fail? They'll also look at the design specification, how the program fits together. So, okay, where are the weak links? Where can this design fail? And they'll look at the code too and say, okay, here's how I wrote the code. What can I do to make this code fail? So here's an example of this actually. So hello. There it is. Okay, so this is an example of someone's loan calculator that they turned in. I've actually made some changes here to introduce a bug. So there is, I'll have a loan amount of $100, annual interest rate of $10, and a monthly payment of $10. And you run the loan payment calculator, everything looks good, okay? And so I think, okay, what are some corner cases? What are some edge cases, some different ways of doing this that might cause this loan payment calculator to fail? All right, so one of those is, what happens if the monthly payment is really close to the loan amount? So let's say if it's $99, what does that look like? Well, it takes 2 months and it costs $100, and I can do the math by hand and see that that looks right. Well, what if the monthly payment is more than the loan amount? So it's $101. Well, now look what happens. It says the loan payment takes 1 month and it costs $100.83. Well, that's more, that looks fine, actually. But let's say it's $100 even. So now it's saying the same thing. But because the loan payment is only $100, the actual payment that month is more than the loan payment, or the monthly payment. So that's actually wrong. Version 2, which is actually the right version of the program, says it's supposed to take 2 months to do this. So this is the calculator. The point is, the calculator here is pretty close to being right, but it was this one special case where it didn't work right. And so you'll want to think about that when you work on your own programs. What happens if the monthly payment is exactly the same as the loan amount? Try that out and see what your program does and make sure that it does the right thing. You don't have a situation where the payment for any month is actually larger than the loan payment, or the monthly payment is supposed to be. All right? And so in the test plan is still reviewed by designers, coders, and testers. People that write code should know how to test code. People that are testing programs oftentimes are software engineers as well. That's definitely the case at Microsoft. Some places they're not, but most good testers know how to program themselves, and they're writing programs to do testing for them, to automate this testing process. All right, and then the final phase is this release phase. And so in the release phase, you're working closely with customers again to validate that the program you've written meets their expectations. You also are getting feedback for the next version of the program. So you say, okay, here's this program. You can take it, you can use it, this is great, and what do we need to do next? You're also maintaining the program, so if they have problems with it, you can fix those problems that they have. And the end result of this, hopefully, is a happy customer who likes what you did for them, and you may or may not get paid for that. Depends on whether that was part of the plan. I mean, certainly you can write a program for yourself and not get paid, but in money anyway, but you can get paid in satisfaction of knowing that you wrote the program to do what you wanted it to do, or for somebody else, or maybe it's ad revenue, and the program is downloading for free and all that kind of stuff. But if you're a professional software engine programmer, then you better get money from something. All right, any questions about this software development lifecycle phases?
Can you go to testing?
What's that?
Can you go back to testing?
Back to testing. And I'm recording this for the video as well, so you can get it from there. And I'll actually post this presentation file on the class website as well, so you can look at the text that way and remember these different things. How about the people that aren't looking at this presentation now? Do you have any questions about this? Do you know what we're talking about? How's the basketball game going? Okay, that's good. What's that? Yeah. All right. Okay, so sometimes this life cycle doesn't always go as planned. This is a favorite graphic that kind of talks about how this can go wrong. Obviously, what they're talking about here is you're building a swing in the tree. The customer explained it. Obviously, it looks kind of strange. They didn't do a great job explaining it. That happens all the time with customers. How the project leader understood it. Obviously, this is a swing that won't work. How they designed it. Well, they fixed that problem by cutting a hole in the tree. How the programmer wrote it. That obviously won't work. How the business consultant described it, which we didn't talk about that kind of stuff. How it was documented. There's nothing there at all. That's pretty common to have documentation that's not helpful at all. What they installed, they put a rope in there and that was it. How they were billed for this huge roller coaster, you always seem to pay more than it's worth. How it was supported, nothing there. And what the customer really needed was a tire swing, and they had it all wrong to begin with. So it's kind of a funny look at how all of these things can go wrong. Depending on how well you do each phase, you can have these kinds of problems and wind up producing something that the customer didn't want or didn't need. It's a process called feature creep, where you add things that the customer didn't ask for because you think they sound good. You know, it could be anything like that. So it's really important as you're going through this process to make sure you're building the right thing and you're doing it correctly. There's actually several different ways of implementing this thing. Many years ago, they had this thing called the Waterfall Model, and they followed that quite a lot. And a lot of companies will still do this, where they basically, you go through each phase once, and when you're done, at the very end, you ship the product, and that's it. How long that takes depends on the program, but you go through the requirements analysis phase. When you're done with that phase, you move on to design, and you never come back to requirements analysis, because you've done all the work there. You need to just keep going along. And there are some advantages to doing it this way. You can get things done. In some cases, you can get them done faster, but in other cases, you can wind up at the end a lot further away from what the customer really wanted than you thought, mainly because you kind of need to go back and do some of these things. So nowadays, it's more common to do this kind of spiral model, where you start in the middle here, and you're gathering requirements and doing all of those, going through all the phases, but before you release it to the customer as your final product, you'll go through the phases again. And so you're working with the customer a lot more often. You're continually showing them, here's what we have so far, what do you think? It's very common when you're working with customers, you say, well, here's what we think the program should do, and you describe it in words, and you can draw big, pretty pictures on the whiteboard and all that, and they'll say, that's great. You go and you build a prototype that kind of does that and show that to them, and then they'll say, oh, well, that's not what I wanted at all. I wanted this over here. And they don't know what they want until you show them what they don't want. That's very common, and so it's really beneficial to continually work with the customer and go through these phases again and again, getting more and more detail until you wind up at the end with the final product. All right, any questions about the software development lifecycle? Now, how does this apply to your final project? So with the final project, you're kind of needing to go through these phases. So you should be thinking about all of these phases for your final project. Instead of just, in the past, you've kind of, for the programming assignment,
is how, tells you industry specific way of how software is developed. As you have seen in the video, there is a requirement analysis. First you gather requirements from the customers or the end users or the clients. Then after gathering requirements, you pass that particular requirement to the coding team or the development team, where they write the codes on the software, whether it's written on, say, Java language or C language or C++ language, ASP.NET language. There are different number of software languages are there. So at the coding part, the software developers write the code. Then once the code is written, that particular code is being sent to the testers. What is the role of the testers? Testers test the respective software codes. Then once tester tests the codes and finds that the code is okay, they deploy the code on the server. Then when the code is deployed on the server, the software is being ready and the end user or customer can access that particular software. So this is a software development life cycle phase. This is how a software development life cycle takes place as the industry's best standards. Now there are lot of different software models are available. Like Waterfall Model is there, then Agile methodology is there, Scrum methodology is there. So there are different models are there, software development lifecycle models are there, which is being followed for the development of the software. Clear to all? Any questions, any doubts, anybody? Okay, so let me play another video for you. Just enjoy this video. This video is also on information technology.
मुश्किलें कभी पूछ के नहीं आती और तब तक नहीं जाती जब तक हम उनसे सबक नहीं सीख लेते। तुम तैरना चाहते हो तो मैं भी वही चाहती हूँ। तुम्हारी जीत में मेरा हिस्सा है, तुम मुश्किलों में क्यों नहीं? तुम नहीं जानते कि तुमने जो सीखा है वो मैंने भी सीखा है, कि हिम्मत सिर्फ तब नहीं दिखाई जाती जब दिखाना आसान हो।
Your career is your business. In this tutorial we will help you understand how to build a technical career path for yourself that starts with building technical expertise and grows into developing technical leadership. A practical guide for all IT professionals. Let us start by understanding the typical IT career path in any big organization. When you get out of your college and decide to pursue a career in information technology, you start as a trainee. At this stage you focus your efforts on gaining more and more knowledge about your chosen technology. And you take roles that expect you to do code development, programming, or exhibit other technical skills, like testing or documenting. In next stage of a career you broaden your technical expertise. and you start gaining depth in many technologies. Here you grow into roles demanding technical design, technical analysis, or project implementation. At this level you start getting exposure to project management and leadership concepts. As you grow further, professionals start expanding outside their technical domain, and learn functional and business alignment. You start becoming more accountable and take people management and organization development roles. This is the entry stage to senior leadership roles, demanding cross-business and cross-domain exposure. You are expected to do business development, change management, and lead many concurrent projects. The next levels from here take you to IT leadership roles. You are expected to exhibit thought leadership in technical domains, help setting IT direction for department or your business unit, and do technology selection and application. You start becoming responsible for major projects and change efforts. Your cross-business and cross-functional skills are in more demand at this stage. Next roles are the CIO or CTO roles that are responsible for overall technical strategy of the entire company. You decide and manage outsourcing and vendor partnerships. You represent your organization in technical industry networks. You are expected to strategize and lead large organizational technology-driven changes. Here you are in partnership with business and generally report to the CEO of the company and need to create IT value proposition. Great. Now how do I plan my career so that I can move from one stage to another? How do I travel the path from stage 1 to the final stage? In this tutorial we will expose you to some skills that you can acquire to continue your career growth. Moving up in the career path. This is our generic career roadmap. Why it takes time for a professional to move from lower to higher roles. What is it that is changing as you are growing in the ladder? As you start maturing into seniorate roles you improve on your technical skills both in depth and breadth. You start adding more value and bring more expertise on table. You gain more competencies that drives you towards acquiring leadership and management traits. Your responsibilities continue to grow and your leaders expect more and more from you. You start managing others and need to learn people management skills. As you grow higher your job satisfaction levels increase. Your compensation also continues to grow and you will be surprised that it does not really matter the way it used to be. You are expected to take decisions and bear the responsibility of their success and failure. You are expected to evaluate risks and opportunities. You become strategic at the top of the pyramid and now people look at you for their answers. You need to provide thought leadership and set directions, goals and objectives for your department. You need to set the vision and direction for the IT in your organization. You motivate and people follow and execute your dreams. How do you achieve this transition smoothly? How do you ensure you have the necessary skills when you are making career jumps? Moving up in the career path. This is our generic career roadmap. Our goal is to move higher in this pyramid using the ladder. But we need to find out what we need to learn to be able to get onto the next step in this ladder. What are the distinguishing skills helps you transition from one role to another? Let us explore those skills. Let us understand what employers demands as you grow higher and higher in the chain. One is technical skills. We start our career by learning any emerging or established technology. Tough business problems require technical expertise and analytical thinking, and technology professionals are expected to keep pace to changing technologies. 2 is functional knowledge. IT functional consultants are the experts having knowledge of concepts and business processes, with understanding of business flows, with added capability to analyze underlying software functionalities in comparison to business expectations. Here you bridge the gap between business and technology. 3rd is domain knowledge. Domain knowledge is knowledge about the environment in which the IT systems operates, and it encompasses the understanding of the industry dynamics and business processes of the target enterprise. IT professionals provide IT solutions to various industries that need to be tailored to the unique demands of each industry and its dynamics. For these solutions to be sustainable and effective, they must be designed keeping in view the present and future dynamics of the industry, and that can be achieved only by having domain expertise of the industry. Fourth are the IT leadership skills. It encompasses general leadership skills, project management, process leadership, change leadership, and enterprise and strategic thinking. Now that we understand TFDL matrix, that is technical skills, functional skills, domain knowledge, and leadership skills, let us understand what constitutes technical skills from a career perspective.
Not clear to you? Tell me. Daisy, just tell me what is not clear. Okay. So what is not clear in the slide? They are telling, this particular video is telling you the IT hierarchical structure, how you rise in the IT. First you become operator. Then from operator you become developer, software developer or programmer or coder. Then from developer you become business analyst. Then from business analyst you become program manager, or rather project manager. You can say a project manager, you can say a delivery manager. Then after project delivery manager, you become, say, there is one more step which is being missed in between. Then you become IT leader, or you can call it a chief architect or strategist. Then after IT leader you become CIO. CIO is the head of the department, head of IT, that is Chief Information Officer. Now at trainee level you start your career as a trainee. Then after attending the training you become a developer or programmer. Then after developer programmer you become analyst, architect or project manager. After analyst you become program manager or delivery manager. That means when you become a program manager or delivery manager, you have more than one project in your hand and you are responsible for the delivery of the project on time. Then above program project manager you have IT strategist, chief architect and IT leaders. Now the role of the chief architect or IT leaders is to run the whole department, to manage all the projects which is being going on, to frame strategies as per the business requirement, to technically design the system specifications. That is the role of the strategist. Then the overall responsibility of the IT department is being headed by the head of the IT, that is the CIO, which is Chief Information Officer. Okay, Rezi? Okay, so when you move up the ladder from trainee to chief CIO, you need to have, when you rise up the career, you keep on increasing certain skills, or you gain certain knowledge. In what terms? First you learn skills, then you learn values, then you have expertise, then you have competencies. Then when you have competencies, expertise and skills, you start taking responsibilities. Once you start taking responsibilities, you manage a lot of people, you manage a team, you manage a department. When you start managing a department, you have that level of job satisfaction that you have the capability of managing the team of the department. And since you have that capability, you have been paid some good salary wages in the form of compensation. Since you are if you are holding some higher portfolio in your organization, say you are an IT strategist or you are a CIO or you are a program manager, you have the authority of decision making. So you start taking decisions, you participate in strategy meetings, and finally you have the vision and direction. And when you become the CIO, your whole department, IT department, will move under the vision and the direction of your head IT, that is CIO. Clear to everybody? Any doubts, any questions till now? Sunil, Rezi, Sandeep, Sheikh, Kelvin, Satish, Ashok, Sagar Isan. Clear to all? Then, since you being the part of the IT, you need to have certain skill sets, which is first, okay Ashok, Senthil, okay Senthil. So, you need to have certain skills. One is the technical skills, second is the functional skills, third is the domain knowledge you need to have, fourth is IT leadership skills. Technical skills, if you have a knowledge on certain technology, you need to have that skills. You need to have the function knowledge. Functions, if you are working for insurance, you need to have an insurance knowledge. So functional knowledge and domain knowledge is almost the same. Then when you have the technical knowledge, when you have the functional knowledge and domain knowledge, you should have a good leadership skills. That is the IT leadership skills. Now let us see one by one what are they.
Technical skills need knowledge of technology. Or you understand the latest technology, more competitive you are. Products, latest technical products and solutions they offer for business problems.
Your career is your business. In this tutorial we will help you understand how to build a technical career path for yourself that starts with building technical expertise and grows into developing technical leadership. A practical guide for all IT professionals.
Application, enterprise-wide applications that provide solutions to current technological issues.
Let us start by understanding the typical IT career path in any big organization. When you get out of your college and decide to pursue a career in information technology, you start as a trainee. At this stage you focus your efforts on gaining more and more knowledge about your chosen technology, and you take roles that expect you to do code development, programming, or exhibit other technical skills, like testing or documenting. In next stage of a career you broaden your technical expertise, and you start gaining depth in many technologies. Here you grow into roles demanding technical design, technical analysis, or project implementation. At this level you start getting exposure to project management and leadership concepts. As you grow further, professionals start expanding outside their technical domain, and learn functional and business alignment. You start becoming more accountable and take people management and organization development roles. This is the entry stage to senior leadership roles, demanding cross-business and cross-domain exposure. You are expected to do business development, change management, and lead many concurrent projects. The next levels from here take you to IT leadership roles. You are expected to exhibit thought leadership in technical domains, help setting IT direction for department or your business unit, and do technology selection and application. You start becoming responsible for major projects and change efforts. Your cross-business and cross-functional skills are in more demand at this stage. Next roles are the CIO or CTO roles that are responsible for overall technical strategy of the entire company. You decide and manage outsourcing and vendor partnerships. You represent your organization in technical industry networks. You are expected to strategize and lead large organizational technology-driven changes. Here you are in partnership with business and generally report to the CEO of the company and need to create IT value proposition. Great. Now how do I plan my career so that I can move from one stage to another? How do I travel the path from stage 1 to the final stage? In this tutorial we will expose you to some skills that you can acquire to continue your career growth. Moving up in the career path. This is our generic career roadmap. Why it takes time for a professional to move from lower to higher roles. What is it that is changing as you are growing in the ladder? As you start maturing into seniorate roles, you improve on your technical skills both in depth and breadth. You start adding more value and bring more expertise on table. You gain more competencies that drives you towards acquiring leadership and management traits. Your responsibilities continue to grow and your leaders expect more and more from you. You start managing others and need to learn people management skills. As you grow higher, your job satisfaction levels increase. Your compensation also continues to grow and you will be surprised that it does not really matter the way it used to be. You are expected to take decisions and bear the responsibility of their success and failure. You are expected to evaluate risks and opportunities. You become strategic at the top of the pyramid and now people look at you for their answers. You need to provide thought leadership and set directions, goals and objectives for your department. You need to set the vision and direction for the IT in your organization. You motivate and people follow and execute your dreams. How do you achieve this transition smoothly? How do you ensure that you have the necessary skills when you are making career jumps? Moving up in the career path. This is our generic career roadmap. Our goal is to move higher in this pyramid using the ladder. But we need to find out what we need to learn to be able to get onto the next step in this ladder. What are the distinguishing skills helps you transition from one role to another? Let us explore those skills. Let us understand what employers demands as you grow higher and higher in the chain. One is technical skills. We start our career by learning an emerging or established technology. Tough business problems require technical expertise and analytical thinking, and technology professionals are expected to keep pace to changing technologies. 2 is functional knowledge. IT functional consultants are the experts having knowledge of concepts and business processes, with understanding of business flows, with added capability to analyze underlying software functionalities in comparison to business expectations. Here you bridge the gap between business and technology. 3rd is domain knowledge. Domain knowledge is knowledge about the environment in which the IT systems operates, and it encompasses the understanding of the industry dynamics and business processes of the target enterprise. IT professionals provide solutions to various industries that need to be tailored to the unique demands of each industry and its dynamics. For these solutions to be sustainable and effective, they must be designed keeping in view the present and future dynamics of the industry, and that can be achieved only by having domain expertise of the industry. 4th are the IT leadership skills. It encompasses general leadership skills, project management, process leadership, change leadership, and enterprise and strategic thinking. Now that we understand TFDL matrix, that is technical skills, functional skills, domain knowledge, and leadership skills, Let us understand what constitutes technical skills from a career perspective. Technical skills means the knowledge of technologies. More you understand the latest technologies, more competitive you are. Products, latest technical products and the solutions they offer for business problems. Processes, technical processes and how they integrate with business processes. Code, knowledge of underlying code for your chosen technical area. Languages, different software languages to build the code. Applications, enterprise-wide applications that provide solution to current technological issues. Databases, knowledge of databases and database management. Today's business environment is complex and changing at a fast pace. Tough business problems require technical expertise to create cost-effective and sustainable solutions. To build technical expertise you should keep your continued focus on building technical expertise. Also along the way focus on acquiring technical leadership skills. Try to stay current with the pace of change in technology. Gain knowledge of enterprise applications. Build your understanding of technical architecture. Learn quality frameworks for technology delivery like Six Sigma and Capability Maturity Model. Acquire knowledge of project management methodology and certification in project management. Document and learn best practices for code development. If you take care of all these aspects in your day-to-day professional life, you will build a strong technical foundation that will help you at higher levels in your career. Now let us understand what we mean by functional skills. Next important skills for IT professionals are functional skills. Functional expertise is knowledge of business processes and related concepts that explains the nature, causes and effects of individual and integrated business activities. Functional knowledge is the practical, tangible and usable knowledge of a particular business function enabling the possessor capable of performing that activity. Simply
this informative video. Do you all enjoy this video? The different skill set you need to have first in perspective to IT.
अच्छा
That is team
अगर हम
management,
तीनों में से मैं
time
favorite
management,
निकला
thought leadership,
तो तुम दोनों
critical
को बुरा तो
thinking,
नहीं लगेगा ना
problem solving, stress management, coaching and mentoring skills, emotional intelligence, decision making, project management and hiring skills. So do you all enjoy this video, everybody? Is my voice audible to all?
उठो उठो 103 डॉलर निकल गई
Do you all enjoy this video, everybody?
हर आसमां से ऊंची है समंदरों से गहरी
So so that I think the time is almost about to get over.
दोस्ती
I've been done for today's class.
ऐसी
So hope everybody have enjoyed today's class. It's an informative video session class today.
ये नंबर
We'll be meeting tomorrow with the next class.
यारी है
Time to say bye to you all.
यारी है
Just do give your feedback after the class. I request to you all to just do give your feedback after the class.
धूप में
Okay?
जाने कितने
Thank you all. Take care. Bye bye.
ये जली है सोना बन के ये बिली गलियों से गुजरी है बरसों सबरी है ऐसी वैसी हो सकती